you're having a hole and number of shafts. So using this we can study the relation between the type of fit we are using. So there are three types of fit: clearance fit, interference fit, and transition fit. So here we are using hole basis, hole as standard, using hole as standard, and we are using various dimensions of shaft. So from that you have to find out which one is clearance, which one is transition, which one is interference by measuring the diameter of the shaft and try to mate with the hole, and whether it is clearance, interference or transition. So this is hole basis system. You can use shaft basis also. In that, shaft is constant size shaft, and hole size is different. For different tolerance grade hole, you have to check with the constant size shaft. So there is a definite dimension from which deviations are allowable deviation. So which type of deviation it is, that grade of tolerance we can find out from the chart. Here this shaft is usually designated in small letters and hole is in capital letters. So for designations of a fit, there is a basic size. So you just note the size of the hole. Basic size of the hole. This hole size is previously measured, it is 23.03 mm. This is measured using a CMM. We measured already. It is 23.03 mm. And the grading also from the standard chart you have to find which grade it is coming. So the schematic diagram of this one you see this is the zero line, basic size. From this can some tolerance is available from to the top size or bottom size, lower size. So here it is allowable tolerances within this two band, minimum up to this minimum limit up to this maximum limit. So the tolerance range is from this to this one. So it is allowable within this line. There is a specific grade. Similarly for other types of holes, there are some 18 types of grades are there. 1, 2, 3 up to 18 types of grades are there. This A grade, this has a limit of tolerance, range of tolerance. This has another range of tolerance, like that. 18 types of tolerances are there. So for here we can check the hole. Now I told you that the dimensions of the hole is 23. So this is the standard chart for finding the deviations. So this is a chart. In this chart, ES indicates upper deviation, EI lower deviation. So must see which this is the shaft nominal size of the hole, 0 to 3 up to 3 mm, up to 3 to 6 mm this hole, 6 to 10 to 18 to 30. So our hole comes in this shaft, in this range, 18 to 30. Our hole dimensions is 33 micron. This is 23.03 mm. So basic size is 23. Basic size equal to 23 mm. But this is deviation, plus deviation. 23.03 is the measured value. So 30 micron plus plus 30 micron. This is the value. So 30 micron comes within this 18 to 30, 0 to 33. 0 is the lower deviation. Lower deviation is on the basic size itself, 23. Then this can vary. This can vary up to 30. Lower size, yeah, lower size is not this, not lower size is 0 here, and this can vary up to plus ES upper deviation 33 here, 33 micron. From 0 to 33 micron, that is the tolerance range, tolerance band. Within this tolerance band, this whole designation is H8. So the specification is 523 H8. That is the whole designation. Designations of whole. Then corresponding mating part that we can check. I am going to measure this one. So this is usually clearance fit. You see, you can measure the from the micrometer. You can measure. Twenty 22.944944. So basic size is 23. Basic size is 23. So 23 minus this one. So 66 mm equal to 66 micron. 0.066 mm. So 66 micron plus minus 66 micron minus. So from the chart you find out which grade it is coming. 66 micron minus. So this is the chart for shaft. Shaft for sizes, shaft sizes, basic size is 23 itself, 18 to 30. There it is up to 66. 65 to, yes, lower deviation, this is upper deviation, 65 to 149. 65 to 149, the grade of the shaft is D is 10. 65 to 149. Upper deviation, ES is equal to 65, EI is equal to 149 micron. So within this, so our hole comes 66 micron minus 166 micron. Here EI also minus, ES also minus. So 65 to 49. So this comes in D10. So the designation of it is like this: 523H8 D10. This is the designations of it. Now you can see from the chart whether it is clearance fit or transition fit or interference fit. Clearance fit, there is a clearance between the mating hole and shaft. Clearance. So this is really going, there is some clearance. Clearance means the size is 66 micron, lower than the size of the hole, smaller than the size of the hole. So it is clearance fit. So from the chart there are types of this one, clearance fit, and the types of holes here, H8, our hole size H8 or H8, D8, D10, loose running fit it is. From the chart you can find out this is loose running fit. Clearance, shaft is D, into D10 for H8, it is loose running fit. So our the shaft is in loose running fit. Running fit. Now you can check another shaft. So this is clearly insert you can insert clearly, but this is not going smoothly. You have to apply pressure, then only this will make the joint. So for that you need to use a press or any other hammering or like thing, heating and hammering, then only this will make form a permanent fit. So you can just measure. So dimensions is equal to 23.025. So this is deviation is 25 micron plus 25 micron. This is 25 micron more than the basic size. Basic size is 25 itself. Because so now we can, from the chart we find out which the grade of this one. Basis, always the basis size is 23 for this hole and shaft is concerned. Hole is 23 point, measured value 23.03 mm. Or now the shaft measured value of shaft is 23.025. So 25 micron more than the basic size. So plus 25 micron is the deviation. Then from the chart you find out which the grade of the shaft. 18 to 30, 25 micron plus should come. These are plus deviation. Here all these are minus. This is plus. So 18 to 30, 28, 28 to, yes, upper deviation is 28 plus 28, EI is 15 plus 15. So within that range, so our deviation is 25 plus 25. So N6 is the grade. N6. So N6, you know all these numbers. This is suppose this is N, A, B, C, D up to numbers N. This is here N shaft basic size. This is here coming. It is, so this is above the basic size N. N6 N. So each one of these is having 18 number of tolerances. A, B, C, D, each one having 18 number of tolerances. That value each one of the shaft having 18 grades of tolerance. Now this N also having 18 grades of tolerances. Now this is N6. N6 is our shaft grade. So the designation of it is 523 H8. This is constant. 523 is the same hole we are using. So slash N6. This is the designation of it. And which type of fit it is coming, you can check here. That is N6. N6 it is. This is a transition fit. Transition means this is near to the basis size. The deviation near to the basis size is usually transition. Above the basis or above the basis size, it is interference. Transition means these lines, in these lines it will come transition. Above this one, interference. Shaft size is more than the hole size. Then we have to heat the hole, then apply pressure to get the joint. That is like that we can make a permanent joint. So here our shaft N6 or H8 hole, that is H7 hole, and so, okay. Heavy key in fit. This is tight assembly for mating surfaces. Heavy key in fit. This remarks is heavy key in fit. I can read here heavy key in fit for tight assembly of mating surfaces. This is the type of fit N6 and H8 hole. Now we can check another shaft. Yes. Clear, very little clearance, we can check. So 22.5 is 22.964 mm. So the deviation is 36. Deviation is equal to 36 micron. So basis size 23. So from 23 we are getting the deviation 36 in minus negative deviation 36. So from the chart you find out the shaft. So this chart is for shaft 36, 18 to 30, 36 minus 36. So this 20 to 41, F7, this hole is F7. Yeah, upper deviation is minus 20, lower deviation is minus 41, so that is F7. So the designation of it is Y23 H8 F7. F7. So this is clearance with norm shaft F7, F8, F7, H4, H8, H7 hole, H8 hole, and the type shaft F4, shaft F7 and F8. This is normal running fit. So like that we can find out different types of fit. For this one only clearance fit and transition fit shafts are available. For more for interference fit comes in the grade FS like that. So now this is not available. So you can check this two: clearance fit, transition fit, and interference fit. Okay.